Hi, Algebra Prep. We're on Unit 4, Topic 6, Graphing from a Table of Values. Learning to be able to graph from a table of values is very helpful in graphing linear equations like we're going to do today. It's also helpful in graphing quadratics that you'll do in Algebra 1. We use table of values often. If you get stuck and don't know what to do, we can create a table of value and start finding points on the line that are going to allow us to plot some points. So here, if you printed the notes, if you're able to print notes, since we are graphing, I did put a copy of some blank notes guide in there so that way you could print them and have the graphs. If you can't print the notes, that's fine. Just make sure you can sketch some little graphs to do the graphing portion of this. We're going to be still working on linear equations, right? So this whole unit has been on linear equations and being able to accurately work with those. So I'm going to make a note of that up here, right? We're talking about linear equations when we talk about graphing from a table of values. Right, and so y equals mx plus b has been the equation we are graphing from last time, and we're going to do some more of those. We're also going to do one from standard form, ax plus by equals c as well. Because those are the two main forms. There's a third form we'll do in Algebra 1 that we learn how to graph and be able to graph from. So graphing using a table. So let's start by filling in, so I'm going to make this a little bit bigger so I can write in here, the steps, right? So the first thing we're going to do for a table of values is I want us all to use a 4-column table of values. A table of values at least has to a minimum have an x column and a y column, right? X and y are our two variables in our linear equations. I like to use a 4-column table of values when I'm doing my math. So our step 1 is going to be to draw a 4-column table. So it's going to be a table with 4 columns. And what we do is once we create that table with the 4 columns, what we're going to do is we're going to choose, choose at least 4 values or numbers, if you want to think of them as numbers, for x. Now, if you remember back when we talked about at the beginning of this unit, we talked about x as is the independent variable. X is our input. So we're going to input some values of x, then we're going to output some values for y. When you pick these values, I have 2 rules. You need to have at least one positive number. So you need to have at least one positive number and one negative number. You need to have a negative number. You can't just use the positive numbers because we need to make sure that you are accurately graphing. Sometimes when we pick our pick negatives and positives, and we'll realize we had something off in our math. So we need to have, excuse me, at least one positive number and one negative number on our table, right? We're picking 4 different numbers. One has to be positive, one has to be negative. And I'm going to go ahead and put a point in here. We'll get to it when we get to our 4th example. That if we have an equation with an x coefficient, right, the number in front of x that is a fraction, we're going to pick values that are multiples of the denominator. So let's go ahead and fill this in our notes here, and then we'll come back to it when we need to use it. So 4 equations with an x coefficient. Remember, the coefficient is the number in front of x, right? So it's that slope, it's the mx, right? So if there's an x coefficient, so for equations with an x coefficient that is a fraction, because our slope is often a fraction, right, when we're doing rise over run. So if it's a fraction, then we're going to pick values that are multiples of the denominator. And when we actually, we'll take a closer look at this when we actually use it. So that's denominator. Sorry, it doesn't look like a D. All right, so for equations with an x coefficient, or the number in front of x, that is a fraction, pick values that are multiples of the denominator, right? I said we get to pick any values we want for x. Or if we pick values that are multiples of the denominator for our fractional problems, then that's going to keep us all with whole numbers. It makes the math much easier than having to deal with the fraction rules. We won't have to deal with very much of the fraction rules at that point. All right, so we're going to draw a 4-column table. We're going to choose at least 4 values for x. You need to have at least one positive. You need to have one negative, at least one positive, and at least one negative. And if our number in front of our x, if we have y equals mx plus b, and the slope is a fraction, then we're going to use multiples of the denominator. Once we have that done, then we go to step 2. Step 2 is to replace or substitute, right? That's the mathematical word for replace, substitute. So we're going to replace or substitute the variable x with the numbers chosen. So with the numbers chosen, and solve for y. We're going to plug in x and solve for y. All right, so that's step 2. So step 1 is to create our table and pick some values for x. Step 2 is to now plug in those values that we've had for x 4 different times and get 4 different values for y. And then the last step is to plot the ordered pairs and connect the points to make a line. So, right, so plot the ordered pairs and connect the points to make a line. So we're going to plot the ordered pairs and connect the points to make a line. Now, when you connect these points, the line is just like previously. The line extends past the points. So we're not just connecting the 4 points that we are plotting. You're going to make the line go past those 4 points on both sides and has arrows on the end. Remember, we talked about this when we were graphing from y equals mx plus b. Right, we put the arrows on the end to show that this line goes to infinity. It's going to keep on going. So you need to not just connect the 4 points, but you need to connect all the way through those 4 points and then put arrows on the top and the bottom. So that way you're telling us that we're graphing the entire function, the entire linear equation, not just the 4 values of x we picked. Right? We picked 4 values of x, but we want to technically graph the entire function. And putting the arrows on the top and bottom tells us we're going to get that entire function. Another caveat here is right. This makes one straight line. If you start connecting your points and it's like a dot to dot that's like zigzagged up and down, then we need to go back and check our points because something did not quite go right. They should make one straight line, all the points connected, right? No zigzags with arrows on the top and bottom. All right, so that's how we are going to do this math. All right, so now let's go ahead and do it. We have 5 problems we're going to do together because I just want to make sure you get this down. This is such a super important skill set. So let's do 5 of these together. So I think on my next you printed it, we have one here. So I'm going to start. We're going to start here by creating the table. So here's our equation, y equals 2x plus 4. So we're going to create our 4-column table, right? So our first is x here. And then I like to have a nice big, how far are we going to go? A nice big spot here in the middle, because that's where we're going to do our math most of the time. And in the big spot in the middle, we're going to write down the equation that we're trying to solve. That's where we're going to actually do the math. That's why I like to put a big spot there. And then we're going to have a y output in our 3rd column. And then our last column, we're going to write the ordered pair. Make sure we write the ordered pair as a point, so that should be in parentheses. So it should be your x comma y in parentheses, right? So this is my 4 columns. The x column, small one at the front, big column in the middle is your function, your y equals 2x plus 4, so we can do our math there. Then a little column for the y at the end, that's our output. And then the x comma y is the point we're going to actually plot on the graph when we're done. Now, I said you get to pick 4. Yeah, I want you to always have 4 values on your table of values. One has to be negative, one has to be positive. The best values to pick, unless we have a fraction, which there's no fraction here, so we don't need to worry about that, is -1, 0, 1, and 2. Right, just do -1 as your negative value. Do 0, because 0 is super easy math. Then do 1, and then do 2. Right, so we're going to take these values for x here, right? These are my x values. We're going to now plug them in to this equation so we can solve for y, right? So I'm going to do the math here in the middle. So for the -1, when x is -1, I have y equals 2 times this -1 plus 4, right? In order of op says it's 2 times -1 is -2 plus 4. -2 plus 4 equals 2. So when x is -1, y is 2. So my y column has a 2 in it. And then we're going to write the ordered pair, -1, comma 2. That's the point we're going to plot. All right, and then we're going to do that 3 more times. So now the second number we're going to check is 0. So I'm going to say y equals 2 times parentheses 0, where it's 2 times 0, plus 4. Order of op says we do multiply first. So 2 times 0 is 0, plus 4. 0 plus 4 is 4. So 4 goes into my y column. And then my point that we're going to plot is 0, comma 4. When x is 0, y is 4. This is our y-intercept. Anytime x is 0, that's on our y-axis. That's our y-intercept. All right, now let's try for x equals 1. So y equals 2 times that 1, and then plus 4. All right, so we're plugging in 1 for x. It's 2 times 1 plus 4. So 2 times 1 is 2 plus 4. 2 plus 4 is 6. So we're going to plot the point 1, comma 6. So if you're able to create your own t-table for graphing, making a nice big column in the middle to do all your math, this helps you keep super organized and all your work looking good. All right, let's do the last one. Y equals 2 times 2, and then plus 4. Right, so y equals 2 times 2 plus 4, so 2 times 2 is 4, plus 4, 4 plus 4 equals 8. So we're going to plot the point 2, comma 8. All right, so once you have your 4 values of x input, and then you get your 4 values of y output, and you have your ordered pairs, then we're going to come on over, and we're going to plot these points on my graph. So I'm going to go over -1 up 2, so here's my first point. I'm going to go over 0 up 4, here's my second point. I'm going to go over 1 up 6, here's my third point. I'm going to go over 2 up 8, uh-oh, I should have done a 10 by 10 graph. I only did a 6 by 6 graph, right? So it'd be up there somewhere. Just kind of estimate where it goes, right? And then we're going to connect these points and go past them, right? So you're going to connect past them and put an arrow on the top and an arrow on the bottom. So make it a nice big long line with arrows on top and bottom to go all the way through. Okay, so that's graphing from a t-table. We're going to do 4 more problems together. One more very similar to this one. So let's come down here to number 2. All right, so first thing we're going to do is create our table of values to use. So I have x here, and then I'll put my y over here, and then my ordered pair, x comma y, and in the middle here, I have y equals, and if you want to put this as a -1, x plus 3, you can. Remember that coefficient, if it's a negative x, That really just means -1. So if it helps you to put that -1 in front, put that -1 in front. Now this -1 is not a fraction, so I'm going to use those same 4 values for x. -1, 0, 1, and 2. So I'm going to use those same 4 values. We're going to plug in and solve. So I have y equals -1 times -1 plus 3. -1 times -1 is +1 plus 3. 1 plus 3 is 4. Right? So that means the y is 4. So the ordered pair we're going to graph is -1, comma 4. There's my first point on the line. It's a solution, right? This is a solution to y equals -x plus 3, or it's a point on the line. All right, now we're going to do 0. Y equals -1 times 0 plus 3. 0 times anything is 0 plus 3. 0 plus 3 equals 3, right? This is that y-intercept. So I almost don't even have to do the math for this one because we know that b is the y-intercept when we're in slope-intercept form. So that's 3, so 0, comma 3. That's the second point we're going to plot. Right? Now we're going to do solve when x is 1. So y equals -1 times 1 plus 3. So it's -1 plus 3, which equals 2. So y is 2. So when x is 1, y is 2. And then the fourth value for x, y equals -1 times 2 plus 3. -1 times 2 is -2 plus 3. -2 plus 3 equals 1. So when x equals 2, y equals 1. Right, so now I put in 4 values for x. I got out 4 values for y. I had the end, my last fourth column are those ordered pairs to help us graph it correctly. So now I'm going to come over here and we're going to graph. So over -1 up 4. There's my first point. Over 0 up 3. There's my y-intercept. Over 1 up 2. Over 2 up 1. Now I know when a problem is in slope-intercept form. We could have plotted the 3 and then did rise of 1, run of -1, right? And we could have done that. We could have used that. You can use that to check this, but you need to find these 4 points and plot those 4 points because that's what we are practicing now is being able to accurately find values for x, pick values for x, solve for values of y, and plot those points and make sure they're accurate. All right, then connect these, whoops, let's try that again. Connect these lines with an arrow on the top and the bottom. All right, so there we are. There's our first 2 problems. So now I'm going to go to the next page. And we're going to do this problem here. Now this one's a little bit different because this is not in slope-intercept form. This is what we call standard form. We call it ax plus by equals c. So when you talk about the standard form of a linear equation, we're talking about a linear equation that looks like this problem. We see a lot of these in Algebra 1. So we're going to do the same process. So we're going to create our table first. So x here. I have y here. Then I have x comma y here. And I put a lot of space here, but for this problem, it might be easier to do the math down below. We'll take a look at this, right? So the value in front of the x is still not a fraction, so I'm still going to pick the same numbers, -1, 0, 1, and 2. So I'm going to pick those same input values for x. But this time, when we go to solve it, right, this is what we're going to solve. We're going to take 4 times -1 minus 2y equals 10. Now this one's a little bit more challenging because it's not y equals mx plus b. So I'm going to take this problem down below here and I'm going to do, so 4 times -1 is -4. So I have -4, oops, minus 2y equals 10. And then you have to add 4 to both sides. So I have -2y equals 14. And then divide both sides by -2, y equals negative 7. That doesn't look like a negative sign, it's like a dot. Negative 7. Right, so the y is negative 7, the negative 1, comma, negative 7. That's the first point we're going to plot. And then we're going to do the same thing for 0. So we have 4 times 0 here, minus 2y equals 10. I'm going to do this one in purple so we can tell the difference, right? So 4 times 0 is 0. So I have 0 minus 2y equals 10. So minus 2y equals 10. Divide both sides by negative 2. Right? Y equals negative 5. So when x is 0, y is negative 5. Okay, then we're going to do 2 more. So we still got to do it 4 times. So I have 4 times this 1 minus 2y equals 10. Right, so I'll do this one in red. So 4 times 1 is 4. So there we go. Sorry about that. Didn't know what happened. All right, so we have 4 minus 2y equals 10, because 4 times 1 is 4. All right, this time we need to subtract 4 from both sides. So we can get the negative 2y by itself. Make sure that's a negative 2y comes down. 10 minus 4 is 6. Divide both sides by negative 2. Y equals negative 3. So when x is 1, y is negative 3. And then we've got one last problem. 4 times 2 minus 2y equals 10. All right, I'll do that one in green right next to it. So 4 times 2 is 8. So 8 minus 2y equals 10. All right, subtract 8 from both sides. Minus 2y comes down. 10 minus 8 is 2. Divide both sides by negative 2. All right, y equals negative 1. So when x is 2, y is negative 1. So now I have 4 points to plot. So standard form takes a little bit more work than slope-intercept form, but we can still get our points and plot them, right? So I'm over negative 1 down negative 7. So it's right about there, a little bit off my graph. I'm over 0 down 5. Here's my y-intercept. I'm over 1 down 3. And then I'm over 2 down 1. Right, there's my 4 points. Rise of 2, run of 1, rise of 2. I went over too far for this first point. Let me erase them all. Right, over negative 1 down 7 should have been more like right here. And then we had negative 5, and then I had negative 3, and then we had negative 1. That looks better. All right, so let's connect those points with arrows on the top and the bottom. There we are. All right, so this one took a little bit more work to get to that point because it wasn't set up as slope-intercept. But that's the nice thing about doing table of values, because it does not matter if it's set up or not. You can still figure out, if you put in a value for x, you can still solve for y. All right, 2 more left. Last 2 problems. I gave us some with the fractions. These cause us the most grief, I think, because fractions just freak us out. We don't like fractions. But before we deal about the fraction, let's just set up our 4 column table here. So I have x, I have y, what's a skinny y? See if I can write that small. And then I have y equals 1/4 x plus 2 in the middle, right? So we're going to find values of x and plug in and solve for y. Now my values of x this time, if we have a fraction, what we want to do is we want to look at the denominator of the fraction, and we want to use multiples of the denominator. So the easiest thing to do is take that denominator, whatever it is, let's do negative that denominator, negative 4. We're still going to do 0 because 0 is a nice, I love 0. So our negative number is going to be negative 4. We're going to have 0. And then we're going to do positive 4. And then you're going to do what 4 times 2 is 8. So it's like counting by 4s, right? 4, 8, 12, 16. But you got to do one negative. So negative 4, 0, 4, and 8. Those are going to be the values we're going to plug in. So you're going to see it's going to make this math super easy. So let's go ahead and do the math. So the top one, I have y equals 1/4 times And then we're going to do negative 4 over 1 plus 2, right? Make it a fraction. So make that negative 4 and negative 4 over 1 to make it a fraction. Multiply straight across the top. So we have negative 4 over 4 plus 2. Negative 4 divided by 4 is negative 1. Negative 1 plus 2. Negative 1 plus 2 is 1. So by using multiples of the denominator, we're able to make the fraction go away and just have whole numbers. So we're going to plot the point negative 4, comma 1. All right, try the next one. Y equals 1 over 4 times 0 plus 2. Now, we love the 0, right? Anything times 0 is 0. This is my y-intercept. 0 plus 2 is 2. So when x is 0, y is 2. All right, let's try the 4 then. So I have y equals 1 over 4 times 4 over 1 plus 2. So multiply straight across the top. 4 times 1 is 4. 4 times 1 is 4 plus 2. 4 divided by 4 is 1 plus 2. 1 plus 2 equals 3. So when x is 4, y is 3. All right, one last one. Y equals 1 over 4 times, this time it's 8, so I'm going to make it an 8 over 1 to help us do that math easily, plus 2. So 1 times 8 on top is 8. 4 times 1 on bottom is 4. Plus that 2. 8 divided by 4 is 2. Plus that 2. 2 plus 2 is 4. So when x is 8, y is 4. So there we go. Now we've got 4 x inputs, 4 y outputs. Because we picked multiples of 4 for the x's, we got all whole numbers that are going to be super easy to graph. Well, except for the 8 because I'm going to give us a table of 6, but we'll figure that out. All right, so let's go. Start with over negative 4 up 1. So here we go. There's my first value. Then I'm going to go over 0 up 2. I'm going to go over 4 up 3. And then I'm going to go over 8, so 6, 7, 8 is going to be out there somewhere. And then we're going to go up 4. It's going to be right about there. All right, and let's connect these points with an arrow going through like that. So there we are. So we were able, by picking multiples of the denominator, we were able to draw that line pretty easily. All right, one last problem. One more fraction problem, because those cause us the most problems. Whoa, what happened? Oh, let's take a look at one last one here. Why is it way down there? Oh, let me erase that. Let me bring this up. I don't know why it's way down here, so let's go bring it up here. There we go. Let's make our table first. So I have x, and then we're going to put our y over here, and then my x comma y for my ordered pair. My equation is y equals, I'm going to put that negative 2 on top. It's a good idea to put the negative on top or on the bottom, your choice. I usually just put it on top. So y equals negative 2 over 5 times x plus 1. Now again, this is a problem that has a denominator, has a fraction. So we're going to pick multiples of that denominator. So that way we don't have to deal with the fractions. So the first one we're going to pick is take that denominator and make it negative. So we're going to do negative 5. And then we're going to do 0, because 0 is always a great one. And then we're going to do positive 5. And then counting by 5s, you have 5, and then you have 10. So there we are. We're going to use negative 5, 0, 5, and 10 as our 4 values of x. That's going to make us make some easy values for y. So let's plug in. So I have y equals negative 2 over 5 times, this is going to be negative 5 over 1, so we can do this math, plus 1. Right, multiply across top, so negative 2 times negative 5 is positive 10. Divided by 5 times 1 is 5, and then plus 1. 10 divided by 5 is 2, plus 1. 2 plus 1 is 3. So x is negative 5, y is 3. There's my first point. Now let's do 0. 0, I love the 0. Super easy. Negative 2 over 5 times the 0 plus the 1. Right? 0 times anything is 0. 0 plus 1 is 1. So when x is 0, y is 1. My x-intercept, my b, my y equals mx plus b, that b was 1. All right, now we're going to do the 5. So y equals negative 2 over 5 times 5 over 1 plus 1. So negative 2 times 5 is negative 10 this time, very similar to the top one, just opposite sign. 5 times 1 is 5 on the bottom, plus 1. Negative 10 divided by 5 is negative 2, plus 1, which is negative 1. So when x is 5, y is negative 1. And last but not least, I have 10, so y equals negative 2 over 5. We're going to multiply that by 10 over 1, plus 1. Negative 2 times 10 is negative 20. 5 times 1 is 5, plus 1. Negative 20 divided by 5 is negative 4, plus 1. Negative 4 plus 1 is negative 3. There's a plus sign there, right? So this is 10, comma, negative 3. All right, so now we got 4 points to plot. All right, once we have 4 points to plot, then I'm going to come over here and plot them. So I'm going to go over negative 5, up 3. There's my first point. Over 0, up 1. Over 5, down 1. And then we got to go over 10, down negative 3, and that one doesn't fit on this graph since it only gave us a... So if one of your points doesn't fit on the graph, it's okay to leave it off. If all 4 of your points fit on the graph, you should be plotting all 4 points. So let's go ahead and sketch this line. Arrows on the top and bottom. There it goes. All right, so this is the line y equals negative 2/5 x plus 1. All right, that is graphing from a table of values. All right, and then last topic, topic 7, we're going to be doing solutions to linear equations, and then we'll be done with our new content for Unit 4. See you on Wednesday.